Good morning. Today we are working on Lesson 5. The objective is to investigate patterns in vertical and horizontal lines and interpret points on the plane as distances from the axes. So we're going to use our straight edge today, and we're going to start right here with problem 1. It says, identify the pattern in coordinate pairs that result in horizontal lines. So first we're going to start with horizontal lines. And remember, horizontal is like the horizon. So the axis, it says on a coordinate plane A on page 4, plot point H that is 3 units from the x-axis and 4 units from the y-axis. So we're counting 3 units from x. So that's 1, 2, 3. Oh, let me scoot up here. And 4 units from y. 1, 2, 3, 4. That's going to put it right about there. And I'm going to have to slide this paper over. And this is point H. And we're going to mark that off as done. It says, what are the coordinates of the point? So here we start on our x-axis. I'm going to label x-axis. Y-axis, and we always start with our x-coordinate first when writing our coordinate pair. So we're going over 1, 2, 3, 4, and up 1, 2, 3. So the coordinate pair is 4, 3. Record the coordinates of H in the chart. So there's down here toward the bottom. There's a chart for H, and our coordinate for X is 4, our coordinate for Y is 3, our coordinate pair is 4, 3, just like that. Back up to our plane. It says plot a second point I at 10, 3, and write its coordinates in the chart. So I is going to be 10, 3, 10, 3. So up here, we're going to go over 10 on our x-axis. 1, 2, 3. Oh, look, right down here is the number 10. And up 3. 1, 2, 3. And these grid lines make it nice and easy to follow. And that is point I. So we are done with step 4. Step 5 says, plot a third point J at 8, 3, and put the coordinates in the chart. J is at 8, 3. Our coordinate pair is 8, 3. Back to our chart. I can go from 5, 6, 7, 8, and up 1, 2, 3. And there's my point for J. And we're going to check that step off. So 6 says, what do you notice about these 3 points and their coordinates? Well, if I look at these 3 points, I notice that they're all on the same line here. And that would be the coordinate for y, which would be 3. So we're going to write they all have 3 as their y coordinate. It says use a straight edge to draw a line that goes through H, I, and J. Label the line W. So here is my straight edge. The table's bumped up a little bit. We're going to try this way. And this is called line W. So over here on the end, we label it line W. What do we notice about line W? What do you notice about line W, Miss Purdy?
Well, I noticed that it is parallel to the x-axis. That's one thing. And it looks like all of them have the same y-axis coordinates.
Okay? So over here on our paper, it says, what do we notice? Well, Miss Purdy notices it is parallel to the x-axis. And since all those points are on the same y-coordinate, that means this line is perpendicular to the y-coordinate. I'm sorry, the y-axis, and perpendicular to y-axis. Does the line W ever intersect the x-axis? So if I were to draw this line forever and ever and ever and ever, Miss Purdy, do you think it would ever intersect the x-axis?
No.
No. Finish this sentence. Line W is parallel to the x-axis. Does line W ever intersect with the y-axis? Well, if we look right here, here's the y-axis, there's our line W, and it sure does. Yes, it does. The next question says, what are the coordinates of the intersection? Miss Purdy, can you help me find these coordinates?
Well, the first coordinate would be, we would look for the x-axis on the x-axis, but it doesn't go anywhere, so that would be 0.
And then our y-coordinate would be?
1, 2, 3.
3. So, the coordinates of the intersection are 0, x, 3, y. It says, what kind of angle is formed at the intersection of line W and the y-axis? Well, if I take my sticky note here, and I know that this is a right angle, I can stick my sticky note in there and it fits perfectly in that corner. So I know that it is forming a 90-degree or right angle. Can you see that? There we go. What kind of angle formed? 90-degree or right angle. What is the name of intersecting lines that form a right angle? And we call them perpendicular. Perpendicular lines form right angles. Number 16 says, finish this sentence. Line W is perpendicular to the, well, it's perpendicular to the y-axis. Okay, 17 says, plot points K and L so that they are on line W, then record their coordinates in the chart. So we get to make up our own K and L. So I'm going to plot K. Right, let's see, I'm going to scoot this up so you can see my chart too. I'm going to put a K right here. I'm going to call that point K. And I will put a point right here on the very last line and call that L. So to find the coordinates, I count over on the X, 1, 2. So K is 2X. Whoops, not K. And 1, 2, 3, Y, and all of them should be 3. So I'm going to go ahead down here and assume that L is 3Y, and I'm going to count over. Here's 10, 11, 12. So L is 12X, 3Y. And now we write our coordinate pairs. K is 2, 3, and L is 12, 3. Next it says, looking at the coordinates, let me see, there we go. Looking at the coordinates on this line again, what can you conclude about the coordinates of points on the same horizontal line? And that's kind of what I said when I filled in my chart. They all have the same what, Miss Purdy?
They have the same y coordinates.
They all have the same y coordinate. What are the coordinates of two other points that would fall on line W but whose x-coordinates are greater than 12? Well, now we get to make them up, and we can be really outlandish with it. So I know a number greater than 12 is 100. And if I wanted it to still land on that same line, what would my y-coordinate have to be, Miss Pretty?
3.
103. And we can do one that's not so crazy. How about 18, 3. Number 20 said, would these points be visible on the part of the plane we see here? Why or why not? Do you think it would be visible, Miss Purdy?
No, because it looks like that one only goes to 12.
Our plane ends at 12, and that is that. Number 21 says, would the point with coordinates 15.5, 3 fall on line W? Explain. Well, I know that the y-coordinate is 3, and any point that lands on 3y would be on the same line. So even if it's 15.5, yes, it would land on that same line because it has 3 as its y-coordinate. Hang on here just a second. We're going to skip down here to number 23. It says, how could you create another line that is also parallel to the x-axis? Well, all I would have to do is make another line that is perpendicular to y. To the y-axis. So if we wanted this line to be a greater distance from the x than the w, what would you need to think about? So if I wanted this to be further, my next line to be further away from the x-axis, I would need to think about how high I need to go on the y-axis. It says, how could you create a line whose distance is less than w's? Well, if I want a distance less than this, I would need to make it smaller than 3. So to make it further from x, it has to be greater than 3. To make it closer to x, it has to be less than 3. So we're going to make another line, and we're going to put a point at 4, 9. So I'm going to count over on my x. 1, 2, 3, 4, and up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is point 4, 9. And I'm going to also put a point at 7, 9. So here's 5, 6, 7, and up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And do you notice these two are already on the same line? And I am going to, let's see, can you see? Trace my line through those points. And this is line Q. And line Q is parallel to line W. Now quickly, before we run out of time, I want you to see one last thing. Here, you can also see that we can make lines that are parallel to the y-axis. The only difference is that every point on these two lines would have to fall on the same x-coordinate. So if you look here, point D is 2.5, E is 2.5, and F is 2.5. They all have a different y-coordinate this time. So we can make parallel lines to y if they have the same x-coordinate, and they would be perpendicular to the x-axis. Don't forget to do your exit ticket.